Okay, today we're going to talk about congruent triangles, kind of building on what we did in the video yesterday and in class today. First thing you want to do is kind of define what it means to be congruent. That definition has not changed from how we've used it before. It means the same or equal. And the way that we're going to use it today, instead of, we've been using it to talk about line segments, angles, today we're talking about it in terms of entire polygons, specifically today triangles. So that next definition, congruent polygons or two polygons are congruent if and only if their corresponding parts. Oops. Corresponding parts, my bad, are congruent. So what do we mean by corresponding parts? Corresponding parts are the matching parts of two polygons. This will make a little bit more sense once we actually take a look at it. When we talk about congruence and corresponding parts, another way that we can describe congruence is if I take one shape and I can do something to it, I can turn it, I can shift it, I can do something that is going to map it directly on top of another object and everything will be the same, those are congruent polygons. All of those pieces that we want to make the same are the corresponding parts. So if we take a look at this next little diagram, our corresponding angles, for example, the first one that I'm going to point out is angle ABC, which is this right here. Its matching part in the other picture is this one, HJK. One giveaway on that is that the picture tells us that they're both equal, because you'll notice all the different notch marks and all those different angles showing equality. But again, if I think about, for example, taking this and kind of flipping it over, that angle is going to fall right in that same spot, if you can kind of visualize that. So some other corresponding angles that we have in this picture is angle BAC, and the angle that corresponds to that one is KHJ. And again, we'll notice that they both have two notches on them, showing they're equal. And then our last one is the one with three notches on it, HKJ and BCA. Those are our corresponding angles. The next one it asks us to look at is the corresponding sides. So same thing goes there. I'm looking at the sides that if I turn that top triangle, and the sides are going to fall right on top of each other. And it's all, again, showing us that we've got some equal sides. So the first one I'm going to look at is AB, right here. Its corresponding side on the other triangle is HJ. So then I've got BC and KJ, and finally AC and HK. So if I've got all of those parts, and basically what I'm saying is that AB and HJ are equal. I can put an equal sign between all of these, all the angles and all of the sides. So I've got every single corresponding part equal to one another. So what I'm going to able to say then is triangle, I'll call the first one CAB, is congruent to triangle KHJ. And my reason there, you're going to see this a a lot in these types of problems. Is I'll point you to right down here where it says corresponding parts of congruent triangles are congruent. CPCTC. You're going to want to memorize that little mnemonic because we're going to use it a ton to be able to prove that different triangles are congruent to each other. So before we move on, go ahead and try example 1 by yourself. Pause the video to see if you can identify those different corresponding angles, corresponding sides, and then what your congruent statement would look like. So pause the video and take a second to do that. Okay, this next part we're going to jump back down to the CPCTC, and we're going to use it to find the values of x and y in these two pictures. We're going to do this very similar to how we've been doing other things. We're going to see what we know about these angles. Basically what I'm doing here is I'm assuming that these two triangles are congruent. So if I'm doing that, I want to identify what the corresponding sides are. Just by looking at this, I'm going to say, now this isn't the best example because you could make an argument for there's a couple different places that could be corresponding that we don't really know. But something that I can pretty confidently say is that this angle corresponds to this one. Just by looking at it, I could map this picture completely onto the one on the right. So, that being said, if I'm saying that these are congruent triangles, then I'm going to say, okay, 4y minus 14 equals 40. And then that's just a normal algebra problem. 6y equals 54, y equals 9. Similarly, to find my x, I can pretty confidently say that ng is corresponding to it over here. So I can say x minus 2y equals 7.5. But instead of x, I know what x is equal to now. Or sorry, I know what y is equal to. Y is 9. So x is equal to 25.5. See if you can do the same thing with this next one. You try to find the values of x and y there. Moving on to the back of this sheet, one of the theorems that we're going to take a look at in this unit is called the third angles theorem. And there it says if two angles of one triangle are congruent to two angles of the second triangle, then the third angle of the triangle is congruent. So, we can logically that makes sense. Because we know that all triangles are equal to 180 degrees, so if we got two angles equal in two different triangles, it's a pretty good bet that the third one is equal as well. What I'm going to do is I'm going to show you the proof of that, which I know proofs gave us a little bit of trouble before. Don't worry about this too much right now. We'll talk about it more in class. So if you just want to sit back and watch, that's completely fine. Remember the first thing that I'm going to say, and typically you're going to be given your statements, and you just have to come up with the reason. But the first thing I'm going to say is that angle A, actually I won't say angle A, because that's what we're trying to prove. Angle C is congruent to angle K, and angle B is congruent to angle J. And the reason we know that is because it's given to us. The picture shows us that this angle is equal to this angle, and this angle is equal to this angle. So, I've said before I'm not going to be too picky, but sometimes you'll see in these, because this is talking about the angle itself, what I care about is the measure of the angle. So, I'll go a step further and I'll say, okay, then the measure of angle C is equal to the measure of angle K, and the measure of angle B is equal to the measure of angle J. And the reason for that is the definition of congruent angles. Because saying two angles are congruent is it's implying that their measures are the same, but sometimes they'll ask you to just come right out and say that. Okay, the next thing I'm going to say, and again, like I said, typically you are going to be provided with these reasons. I'm going to say the measure of angle A plus the measure of angle B plus the measure of angle C equals 180. And I'm going to say the same thing about the other triangle. Measure of angle J plus the measure of angle K plus the measure of angle L is equal to 180. And the reason for that is that triangle sum theorem that we talked about the other day. And basically all that means, that's something that you already know, all triangles equal 180 degrees. So that's all that's saying for us. Okay, let's see, where do I want to go now? I'm going to move up here. I didn't give us enough room, so I'm going to finish the proof over here. Sorry if this drives you crazy. So this is a statement, and these are my reasons. So let's see, statement number 4. So if I've got both of those things equal to 180, I'm going to say that they're equal to each other. So I'm going to say the measure of angle A plus the measure of angle B plus the measure of angle C equals the measure of angle K plus the measure of angle J plus the measure of angle L. And you may recall, because we did it a little bit with a different problem that we worked on, the reason for that is the transitive property. Because if I said each of those are equal to 180, so if they're both equal to the same thing, then they're both equal to each other, and that's transitive. Okay, we're almost there. Number 5. So for step 5, this thing starts to get a little bit crazy here. I'm going to say now the measure of angle A plus the measure of angle K plus the measure of angle J equals the measure of angle K plus the measure of angle J plus the measure of angle L. My reason for that is substitution. The reason that is because I just took what I had in number 4. If you think back to what we did on the first line, we said all of these angles were equal. So instead of having angle B, I'm going to say that's the measure of angle J instead. And I'm talking about right here. I substituted that in for my B. And I did the same thing with C and K. The reason that helps me is my next step says, okay, then the measure of angle A is equal to the measure of angle L. reason for that being, oops, this should be a 5 here, and this is a 6. Subtraction. Because if I take these two things that I've got a measure of angle K and a measure of angle J on both sides of my little equation in step 5. So I get rid of them and I say, okay, measure of angle A is equal to measure of angle L. And that is exactly what I want. Because we said that we were proving that theorem that we had up here. And that, my friends, is the proof. Because we were basically showing, we wanted to show that those two angles were congruent if these were as well. So, again, do not worry too much about this. We are going to practice doing something similar to that. But if you're confused after that, I'm sure you are, because it's a lot of stuff and it's kind of crazy all over the place. That's okay, and we'll talk about it more. The final thing on here are these different properties of triangle congruence that, once again, we will use in various different ways to prove that different triangles are congruent to one another. So we'll take a look at those next class. Again, don't let that proof scare you. We'll try to clear up some confusion.